Have you ever met someone who's just incredibly confident, but also completely, totally wrong? Well, it turns out AI can have the exact same problem. Today, we're going to dive into this fascinating glitch where an AI's self-belief literally became its own worst enemy, and how a brilliantly simple fix made it dramatically smarter.
So here's the central mystery for you. Just picture an AI learning to play an old Atari game, right? It's practicing, it's getting better, and its internal meter for, hey, how well am I doing, is just shooting through the roof. But then, its actual score on the screen starts to nosedive. It becomes utterly convinced of its own greatness at the exact moment it starts failing miserably. So how on earth does that even happen?
Okay, to solve this puzzle, we've got to pop the hood and look at the engine that's driving this kind of AI learning. It's an incredibly powerful tool, but as researchers found out, it has this hidden flaw, a kind of built-in optimism trap.
And that engine is called Q-learning. The easiest way to think about it is like a little mouse in a maze looking for cheese. At every single junction, every possible turn is an action. The Q value? Well, that's like the strength of the cheese smell coming from that path. A really high Q value is a strong whiff of cheddar telling the mouse, yes, this way leads to a big reward.
But here is where things get a little tricky. It's this thing called the maximization step. So when the AI is learning, it's constantly asking itself, okay, of all the things that could happen next, what is the absolute best case scenario? It then takes that 1 in a million jackpot value and uses that to teach itself. I mean, sounds pretty smart, right? What could possibly go wrong?
What goes wrong is the AI starts believing its own hype. Seriously. Because it's always fixated on the most optimistic outcome. Even if that outcome was just some random fluke, it starts to get a really skewed view of reality. It begins to think every path is paved with gold. As the original researchers put it, this leads to over-optimistic value estimates. And you can see the problem laid bare right here in this graph. Just look at the pink bar on the left. That's your standard Q-learning. See how as the AI gets more and more choices, its estimation error just skyrockets? It gets more and more detached from reality. But now look at the purple bar, which is the new solution. It just stays flat, rock steady, it's grounded, no matter how complex the situation gets.
Now, this wasn't just some theoretical problem in a little toy example. This optimism bias, it turned out to be a major Achilles heel for one of the most celebrated AI models of its time.
And that brings us to the hero of our story, the Deep Q network, or DQN for short. Look, this wasn't just a small step forward. This was a giant leap. For the first time, a single AI could learn to play a huge range of games and at a superhuman level, just by watching the pixels on the screen, exactly like you or I would. It was a massive, massive breakthrough. But as they let it train for hours and days playing millions and millions of frames of these games, they started to see that strange pattern emerge, a real ghost in the machine.
So first, the AI's own predicted score, its internal confidence meter, would start to climb. And I don't mean just climb, I mean soar to completely unrealistic astronomical heights. It was absolutely certain it was about to become a gaming god. And then came the paradox. At the very moment it thought it was invincible, its actual score would just crash and burn. It was a perfect example of the Dunning-Kruger effect, but for a machine. The AI had learned to be supremely confident, but it had forgotten how to actually be competent. So how do you fix an AI that's just too optimistic for its own good? Well, the solution is incredibly elegant, and it's something we humans use all the time. You just get a second opinion. So the core idea behind the fix, which is called double Q learning, is to break that toxic loop of optimism. You simply decouple the act of choosing the best move from the act of figuring out how good that move actually is. So how does this second opinion work in practice? It's a surprisingly simple tweak. The new model, double DQN, uses two neural networks that work together. The first network, the online one, does what it always did. It looks at the game and picks what it thinks is the absolute best move. But, and this is the key, instead of evaluating its own move, it hands it off to a second, separate target network and basically asks, hey, how good is that move really?
And that one little change makes all the difference. The original DQN was like having a player who's also the referee. I mean, a clear conflict of interest, right? It was judging its own brilliant ideas. Double DQN brings in an impartial judge. That simple separation of duties is enough to completely break that destructive cycle of overconfidence.
So the theory was sound, but did it actually work in practice? The researchers put it to the ultimate test, a head-to-head showdown against the original, overconfident DQN across the full suite of 49 Atari games.
And the results, they weren't just good, they were absolutely staggering. The median score, which measures typical performance, nearly doubled, going from 47% to 88% of a professional human gamer's score. And the average score, it more than doubled, jumping from 122% to an incredible 273% of human performance. This wasn't a minor improvement, this was a quantum leap. And if you want to see just how big a difference this made, just look at the game Double Dunk. The original AI was terrible at it, scoring just 17% of what a human could do. But with the new, more grounded approach, the AI didn't just get better, it became an absolute superstar, scoring almost 400% of the human score. Now that is the power of a reality check. So, what does all of this mean for the bigger picture? Because, let's be honest, it's about a lot more than just getting high scores in old video games. It's about building AI that learns more reliably and, really, more effectively. So let's just put it all together. We've learned that AI can fall into this very human-like trap of over-optimism. The fix, it turns out, is to separate the act of choosing from the act of valuing. And this simple second opinion leads to far more stable learning, dramatically better performance, and it completely reset the bar for this entire field of AI research. So, what's the big takeaway here? It's that the double DQN breakthrough wasn't just some performance hack. No, it was a fundamental step towards understanding and fixing these subtle, almost psychological flaws that can creep into our complex AI systems. It's really about making AI more grounded in reality. And all of this just leaves us with one final, fascinating question. We just saw a very human-like bias, overconfidence, emerge in a machine. And the solution was a very human-like concept, a second opinion. It really makes you wonder, what other hidden biases, what other ghosts of our own minds are we accidentally coding into the artificial intelligences that are going to shape our future?